wanted to go over some problems that we initially skimmed over in our Chapter 6 test review to make sure that you understand them. So the first one that I wanted to do over again was this number 4 right here. So it said that we have this region bounded by y equals secant x equals x over 3. So I think the hardest part of this problem is just remembering all your trig stuff. So if you can draw the picture, then this intersection point here is going to be at pi over 3, 2. And the reason I got that was because the secant of pi over 3, remember secant is just 1 over cosine. And the cosine of pi over 3 is 180 divided by 3 degrees, which is 60 degrees. So across from 60 degrees, I know I have root 3 over 2. Adjacent, I have 1/2. Cosine is what's adjacent, so 1/2, and 1 over 1/2 is 2. So that's how I got the point pi over 3, 2. Anyway, you didn't really need to know that. Just wanted to help you with that. And so this radius right here is just top curve minus bottom curve because we're revolving around the x-axis there. That's just the curve. That's secant x. And so we have pi r squared, pi secant x squared. The bounds are from 0 to pi over 3. And the antiderivative of secant squared is tangent. You just need to memorize that. One of the derivatives that we memorized was that the derivative of tangent x is secant squared x. It's time for us to start memorizing our trig derivatives. So please make sure you remember this one. It's very important that you know it. So from there, if I didn't have a calculator, how do I figure out what the tangent of pi over 3 is? The tangent of pi over 3, remember pi over 3, 180 divided by 3 is 60 degrees. So tangent is opposite over adjacent. So root 3 over 2 over 1/2, root 3 over 2 over 1/2 is just root 3. And so that's how I get the root 3. And then the tangent of 0, well, 0 is just this point here, 1, 0. And then we have y over x for tangent, which is 0 over 1, which is 0. Remember, tangent is undefined at pi over 2 and 3 pi over 2, and it's 0 at 0 and at pi. So that's how you get that answer. Number 5, I also wanted to go over, and mainly I wanted to go over it to help you figure out the antiderivative. So if we're able to draw the two graphs, then we find that our region is right here, and we see that the e to the x over 2 is on top, and that the x minus 1 squared is on the bottom, and so we are going to do the radius outer squared, and that's really nice because the e to the x over 2 squared just becomes e to the x, and so we know the antiderivative of e to the x is e to the x, so that's really nice. But then when we have our pi radius inner squared, that one isn't so nice because we have an x minus 1 squared squared, and that's an x minus 1 to the 4th power. But how do we take the antiderivative of x minus 1 to the 4th power? We can't really simplify this. I mean, we could FOIL and then FOIL again, which would be just a big pain in the butt. It's much easier to do a U sub. And I know that I need a U sub because, of course, this is unchaining, right? There's definitely a baby there. And this is actually a very clean U sub because if U is x minus 1, then du is simply dx. So I really don't have that much work to do. The antiderivative of u to the 4th du is what I come up with, and that would be 1/5 u to the 5th plus c. And so the antiderivative of x minus 1 to the 4th power is simply 1/5 u to the 5th plus c. And so I just figured out what it was. I didn't mess with my bounds. If I go back to x's, I can just put it back in and not have to change any bounds here. So these bounds are still 0 to 1. And that's just how I solve that problem. Now, please note, people always forget to put in the 0. They just drop it off like it doesn't matter because a lot of times in our problems, we're putting it in for x and we do get a 0. But in this case, it is super important that you remember to put it back in because that certainly does not cancel out. The next problem that I wanted to do was number 11. So this is the graph of y equals e to the x. So that's y equals e to the x. Then we have y equals 2, so that's y equals 2, and x equals -1. So Those are the three things that we're dealing with right there. And then the region bounded is just in between there. So clearly our bounds are going from -1 to this intersection point. But what is that intersection point? That intersection point is where the red and the purple line intersect. And the red was y equals 2, and the purple was y equals e to the x. So where do those two intersect? Y equals e to the x, which equals 2. I have to take the ln of both sides. So ln of e to the x is going to leave me with x, and I just get that equals ln of 2. So that's going to be my bound. This bound is going to be from -1 to ln 2. So that's how I get the bounds here from -1 to ln of 2. And then I just do top curve minus bottom curve to find the area. So that is simply 2 minus the purple line, which is e to the x. So that's how I get the area. My antiderivative of 2 is just 2x. My antiderivative of e to the x is just e to the x. And so that becomes a pretty nice problem for me to solve. How did I get this 1 over e? Well, e to the -1 is just 1 over e. So that's how I got that. Okay. The next part asks us to find the volume when we're revolving around x equals -1. So if I'm revolving around x equals -1, and I drew that right here, so if I'm revolving around that line, well, I need dy slices. So I need to change everything. And you see how I actually only have one radius. I don't have a radius outer and a radius inner because remember, this is the region that I'm dealing with, and I just have that one radius. There aren't multiple radiuses in this one. It is a disk problem, not a washer. And so what is that radius in terms of y's, right? So I had y equals e to the x, and so that's going to become, let's ln both sides, ln y equals ln e to the x, which is just x. So x equals ln y. So this is ln y minus a -1. So that radius is ln y minus a -1. And so that's how I get my radius is ln y plus 1. So pi r squared. Now, my bounds are going to be y bounds this time, right? Because I'm doing everything with dy's. So I need y bounds. So where do I start? I start wherever it hits that -1 because I knew x was -1. When x is -1, what is y? When x is -1, what is y? E to the -1. So that's where I get the 1 over e. And then I go up to this y equals 2 line. So that's a nice bound that I have there. So that's how I get that part. Then in part C, find the volume when we revolve around y equals -1. So that's going to be down here, and I'm rotating now. And so again, this is my region bounded by the red and the purple. And so in this one, I actually do have a radius outer and radius inner because I have this guy, right? And I have this guy. So the tall one is just the red line, which was 2 minus a -1, which is just 3. And then my radius inner, that was my radius outer. My radius inner is going to be the purple, which was e to the x. So e to the x minus a -1, which is e to the x plus 1. And so that's how I get my pi radius outer squared minus pi and my radius inner squared, which is that right there. So that's how I do that. I did this question purely on my calculator, so I just used FNIT to solve. Now number 12 is a cool one, which usually means that you have to think for a moment, but once you do, it becomes really cool. And so in this question, it says, let f be the function given by this big long thing. Let R be the shaded region bounded by F and the line L, which is a line tangent to the graph of F at x equals 0. So it's tangent at x equals 0. Tangent, let's take a derivative. And at x equals 0, let's find it at 0. So if I take the derivative, I get 3x squared minus 4x minus 1. And the derivative of cosine is a bad sign, so minus sine x. And then if I find it at 0, I get 0 minus 0. Minus 1 minus the sine of 0, that's the y coordinate at 0, is 0. So that's where I get that. And so I get it's -1. To find the equation of a line, I now have the slope, I need a point. So the point at 0, just put it into your function. So I get 0 minus 0 minus 0 plus cosine of 0, and the cosine of 0 is 1. And so my point is 0, 1. That's where that point comes from. I just plugged it into my equation because, again, I want the tangent line. The tangent line, I need a point and a slope. So now I have a slope, I've got a point. Y minus y1 equals the slope times x minus x1. I get y equals negative x plus 1, and that must be the line L that it is referring to. Now, when they ask us to find the area of R, how do I do that? The area is just top curve minus bottom curve. That's all I do. And I'm going from here to here. So what is that intersection point? Well, I'm going to just take out my calculator to do that problem. In Y1, I'm going to put the equation. In Y2, I'm going to put this L equation that I just found. Now I'm going to graph. And all of that is not great to see. So I'm going to zoom in a bit. I'm going to just do zoom decimal. I think that'll give me a better window. Cool. I'm much happier with that. I think that they intersect right there at 0, but I'm just going to make sure. So at 0, my y1 is 1, and my y2 is also 1. I just used the up and down arrows to go from y1 to y2, so that is cool with me. And then the other intersection point, I'm going to use second calc intersect, and I'm going to use the right arrow to get over to it. Find the point, press enter, enter, enter. And so there we go, that's my intersection point. Now, I need to be exact here, so I really need to store this intersection point. So I'm going to do second quit, and because I have done nothing else, I've touched no more buttons, that x is going to still have that value of the intersection point that I just found. So I'm going to store that in alpha A, enter. How am I going to find the area? I need to do top curve minus bottom curve, so I'm going to just do math 9. So I'm going to go from 0 to that intersection point, which I stored in alpha A, and then the top curve here is the line, which I put in y2. So choose y2 minus y1, and that's dx. And so that should be my answer to the area problem. I guess in my answer key I didn't write the answer down, but I should have written this. That is my answer. So the next problem says, set up but do not evaluate an integral expression for the volume when we revolve it around y equals 2. Okay, so let me go back to my drawing before I do anything wrong. I always draw. So y equals 2, and I'm revolving here. So my longer line is going to hit that big f of x equation, and my shorter line, my radius inner, is just going to be with that line L. So the radius outer is going to be 2 minus that big long thing, x cubed minus 2x squared minus x plus cosine x, because again, top minus bottom. And my inner is just going to be 2 minus the line L, which was that negative x plus 1. So again, I have pi radius outer squared minus pi radius inner squared, and I'm doing the integral of all that to add up all the slices, right? And so again, I'm still doing x bound, so I'm still going between 0 and a. I don't know why I didn't write a here, I should have. And I just have 2 minus, that's y1, squared, minus 2 minus, that's my y2 squared. If I was doing this on my calculator, this is how I would do it. First of all, make sure that you are in radian mode. You should just be in radian mode for this entire class all the time, always. So I usually just let the pi hang out. I don't deal with it. So math 9 fnnt, again, we're going from 0 to a, and this time I am doing parenthesis 2 minus y1 squared minus 2 minus y2 squared, and I still have dx. And so that is going to be the answer to my volume question, 17.013 pi, or you can multiply by pi at this point. Either answer is great. The other question that I wanted to go over was number 18. Here is f of x is sine x and g of x is negative sine x. And so they're asking us to first find the area of the shaded region enclosed by these two graphs. So clearly the f graph is on top. So I'm going to do the integral from 0 to where do the two things intersect? So where does sine x equal negative sine x? Well, if I solve 2 sine x equals 0, sine x equals 0, where does sine x equal 0? Sine x is 0 when the y coordinate is 0. That happens at 0 and at pi. And so I'm going to do the integral from 0 to pi of top curve minus bottom curve. So that's sine x minus a minus sine x, which is 2 sine x. I'm going to factor that 2 out. And so I have 2 integral from 0 to pi of sine x. The antiderivative of sine x is negative cosine x. Remember, I had let that 2 just hang out. Evaluated between pi and 0. What is the cosine of pi? The cosine of pi is that y coordinate. That's negative 1. So I have, let me just do 2. And then I have negative 1 minus, and then I have negative cosine 0, and the cosine of 0 is 1, so that's again negative 1. And so I have 1 plus 1 is 2, 2 times 2 is 4. So here when I was solving it, you can't see because it's cutting it off a bit, I just factored out this negative, and then right here I didn't factor out the negative. So either way, works, just put in the numbers, and you got the answer is 4. Part B. Find the volume of the solid generated when the region enclosed by the graphs of f and g is revolved around the horizontal line y equals 3. So y equals 3 is above here. So the radius outer is going to be 3 minus a minus sine x. So 3 plus sine x. The radius inner is 3 minus sine x. So I just did this whole thing in my calculator in y1. I just actually put in that whole thing. So I put the radius outer squared minus the radius inner squared, because then I just had to take the antiderivative of that whole thing and remember to multiply it by pi. So then that is all I did in that problem. My bounds were from 0 to pi because, again, I'm still doing dx slices, so I'd already found the intersection points there. Part C. Let h be the function given by h of x equals k sine x. This looks so confusing, and it's so easy. This one is so easy, part C. I would never want you to miss it. Because look, it says the base is enclosed by the graphs of h and g. So this is g, and the other one is h, and it tells you that the k is greater than 0. The h is always on top, right? So if these cross sections are squared, this couldn't be easier. So it's somewhere up here, right? And there's squares. There's squares. So I'm going to do top minus bottom, h minus g. And I'm going to square it. And I'm going to add them all up from 0 to pi. And that's all I have to do. From 0 to pi, I have k sine x minus a minus sine x, because that is my g of x, squared dx. And it tells me that the volume is 8 pi. And so that is equal to 8 pi. So how do I do the next step? I would do the antiderivative of k sine x plus, because minus minus is a plus, sine x squared dx equals 8 pi. Now, the next step that I did here was I noticed that the sign was in common, so I factored it out. So I got sine x times k plus 1, and that whole thing is squared. And then the next step is pretty neat. I can just square each part, right? Because if I have 4x squared, for example, that's 4 squared times x squared. So I just applied that same property. And I did the sine squared times k plus 1, the quantity squared. The k is a constant, right? So it does not depend on x. It's a constant. So I can pull that out. I can only pull it out because it's a constant. Doesn't depend on x. And then I have to find the antiderivative of sine squared x. And for that, I just used my calculator there, and I just used fnint to find the antiderivative of sine squared between 0 and pi. So I would do math 9 from 0 to pi of sine squared, sine x. I just put the whole thing in parentheses like this, squared dx. And you'll see that that is pi over 2, which I recognized it as. If you didn't, you could just, use the decimal equivalent, and that would be cool too. And then you would have solved it. I like to solve this. This was k plus 1, the quantity squared equals 16. So when I take the square root, don't forget about the plus and minus, please. And so I have k equals -1 minus 4, which was -5, or -1 plus 4, which is 3. Remember, they told you in this problem that the k was greater than 0, so you have to cross out the negative solution, and that is how you get that one. So this is a very AP-like problem. It would be good to practice it on your own one more time just to make sure that you get it all out, because we're getting close to the AP exam, guys, and it would be a good one to practice. So the last problem that I wanted to discuss was this one. This one's really cool. They're telling you that 1 over 8 minus 0, integral from 0 to 8 of f of t dt is greater than 2. You might recognize this as the average value of the function between 0 and 8. But one other way to think about this is just let's multiply both sides by the 8 minus 0. So that would mean the integral from 0 to 8 of f of t dt is greater than 2 times 8 minus 0. Why am I leaving it as that 8 minus 0? Because you might recognize that 2 times 8 minus 0 is the same thing as a rectangle with a height of 2 and a width of 8 minus 0. So that's how I'm going to think about this problem. So I'm just going to draw that in for each of them, because now my problem is pretty much saying for which of them is the area under the curve. So let me just highlight this part in yellow. So for which of them is the yellow actually greater than the red? And so once I draw this in, I think it's going to become pretty clear that the only one where the yellow is clearly greater than the red, and the red would just be if I shaded that whole thing in. So you can see that this one just goes up a tad bit, but goes down more. So that's not going to be it. This one, definitely there's more blank spaces below than there is above. But see, this one, there's more above than there is below. And so this right here is my answer to this question, because the yellow region is bigger than the red region. If I were to highlight it, the red region would have been this part here, right? So that's how I thought about that problem. And that's about it for this lesson.